Now see this, state whether the following is true or false. So they have given some statements and you are supposed to state whether they are true or false. First one is, every subset of symmetric relation is symmetric. Is it true? So every subset, so you can take an example like this. Let us say whenever such a question is given, if you are not sure, better take an example and visualize it. Let us say R1 is a relation like this, 1 comma 1, 2 comma 2, 3 comma 3, maybe 2 comma 1, 1 comma 2. Alright, so if this is the relation which is symmetric, then they are saying that every subset is a symmetric relation. Now let me find a subset of this. What is the subset? 2 comma 1. I'll just take 2 comma 1, and what about this? Is it symmetric? It is not symmetric. Therefore every subset of a symmetric relation is not symmetric, right? It is false. So what can you say about this? The set of all symmetric relations, is not closed under the operation subset. Why? Because if you take a subset of a symmetric relation, the result may not be symmetric always. Now the next one is, every superset of a symmetric relation is symmetric. Let's see this. This is a symmetric relation, right? Now every superset, which means whatever you add to this, they are saying that it is going to be symmetric, but it is false. Why? If I add 2 comma 3, right, only element 2 comma 3, then it is not going to be symmetric. Therefore every superset of a symmetric relation is not going to be symmetric always, so it is also false. So again, the set of all symmetric relations is not closed under the operation superset of. What does it mean? If I take a symmetric relation and if I take the superset of it, the result may not be always symmetric, right? It may or may not be, but then it is not always, right? So they are saying every, so not every. Now the next one is, if R1 and R2 are symmetric relations, then R1 intersection R2 is symmetric. So understand this, it is an interesting question. If R1 and R2 are symmetric, then R1 intersection R2 is symmetric. Okay, so they are saying that R1 and R2 both are symmetric, and now they are asking about R1 intersection R2. Is it symmetric or not? Now when will this be not symmetric? This will not be symmetric if R1 intersection R2 is going to contain an element x comma y, and if it does not contain the element y comma x, isn't it? Now think about it. If this contains an element x comma y, where do you think we got this element from? This element we got it only because x comma y is present in R1 and x comma y is present in R2. Then only we get x comma y here, isn't it? Now if x comma y is present in R1, since R1 is symmetric, y comma x should be present there, isn't it? And similarly, since x comma y is present in R2 and since R2 is symmetric, y comma x should be present in R2, right? And now when we are talking about intersection, when we got x comma y, we would definitely get y comma x as well. Therefore x comma y and y comma x will be present in R1 intersection R2. So are you getting the logic here? See, try to understand this. Now these two are symmetric, that is what is given, and now they are talking about intersection. Now I am assuming that intersection is not symmetric. Why will that be not symmetric? Because there might be, I'm just assuming that, right? I'm just assuming that it is not symmetric. Why will it not be symmetric? There might be an element like x comma y present and y comma x may not be present. Now if x comma y is present, how did I get x comma y in R1 intersection R2? Because it is present in both R1 and R2, x comma y, then only I get x comma y here. Now since R1 and R2 are symmetric, if x comma y is present in R1 and R2, they will definitely be present in R1 and R2. Y comma x will be definitely present in R1 and R2. Therefore we will get y comma x as well, right? Therefore R1 intersection R2 is definitely symmetric. It cannot be not symmetric. It is definitely be symmetric, right? So R1 and R2 are symmetric, then R1 intersection R2 is also going to be symmetric. It is true. So what does it mean? The set of all symmetric relations is closed under the operation intersection, right? Now let's talk about union. So what can you say about union? Now again you can argue in the same logic. Let us say R1 union R2 is going to contain an element x comma y and it does not contain element y comma x, and so R1 union R2, let us, I'm just assuming, okay, I'm assuming that R1 union R2 is not symmetric. Why is it not symmetric? Because I'm assuming that it contains an element x comma y and it does not contain an element y comma x. Then it is not going to be symmetric, isn't it? But then how did we get x comma y? Either x comma y is present in R1 or R2. Since x comma y is present and both R1 and R2 both are symmetric, definitely y comma x will also be present in R1 or R2 wherever x comma y came from. Therefore, there is no way you will get x comma y into R1 union R2 without getting y comma x. It will also be present in one of them. So again, under the same logic, R1 union R2 is symmetric, right? So it is true. What can we say? Again we can say the same thing. So what is it? So we can say that the set of all symmetric relations are closed under the operation union. Now what can you say about this set difference? Now we can argue the same logic, right? R1 minus R2. Okay, assume that R1 minus R2 contains x comma y but it does not contain y comma x. Is it possible? Let's see this. If it contains x comma y, then how did we get x comma y from? We got x comma y from R1, isn't it? If R1 is containing x comma y, it will definitely contain y comma x as well. Why? Because R1 is symmetric, right? Now if you think that R2 has removed only y comma x from R1 without removing x comma y, it is not possible. The reason is, if y comma x is present in R2, then x comma y will also be present in R1. Therefore, the entire pair x comma y comma x, either both will be deleted from R1 or both will stay in R1. It is not that we are going to delete only one of them. Therefore, R1 minus R2 is symmetric, right? So it is true. So when I'm talking about logically proving these R1 intersection R2, union R2 and R1 minus R2, I didn't talk about what happens when there are diagonal elements. So there is nothing to prove about diagonal elements. Diagonal elements is not going to spoil anything here. Only thing that will spoil us is if x comma y is present and y comma x is not present, then only we can say that a relation is not symmetric. But we cannot do any such proof using diagonal elements. That is why I didn't talk about them, right? So you can understand from these three rules that the set of all symmetric relations is closed under intersection, union and set difference, but it is not closed under subset and superset operation. Got it? So these are somewhat tricky. So if you didn't understand whatever I explained here, I suggest that you take some examples and then you see it for yourself. If you are not understanding the logical explanation of this, you take examples, you just enumerate, visualize and you see for yourself why it is true. Okay, fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days. And whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.